Okay, our first guest speaker for today is Dr. Dara. I want to, sorry, I'm coming. Oh, Mr. Just, welcome. Sorry, I'm coming. I want to quickly read about Ravi. I'm coming. Okay, meet Dr. Dara Ashiwaya. However, I pronounce her name very well. She's the founder
It's all
and Certified Tech Program Coordinator and Associate Professor of Aerospace Engineering at DNA University. Dr. Ashwaya Dara is the visionary founder of Scafy Tech and Innova World Research Center. With her extensive expertise in aerospace engineering, she is also a dedicated program coordinator and associate professor at DNA University. Dr. Ashwaya Dara will share her insights on cutting-edge technology in space, application of AI and machine learning in space technology. So welcome, Dr. Ashwaya Dara. The floor is yours, ma'am.
Thank you so much. And first of all, I would like to thank the founder of MARVECX for inviting in this session. And all the panel members, I welcome you. And thank you for giving me a platform to discuss about how this AI and ML play a very vital role in this coming generation, especially in aerospace and defense sector. So allow me to share my screen. So where I will give you some of the outlines that how actually the aerospace and defense play a very vital role. I hope just let me know whether my screen is visible or not.
Yes, it's feasible.
Because I got, yeah. All right. So as you can see in my screen that today's topic is going to be application of AI and ML in aerospace sector. And in this talk, I will also give you the highlights, one of the trending research as this topic, as we know that currently how every country is fighting behind climate change and we are taking the actions regarding climate action. So I'm going to present you an idea and some methods and approaches how we can work on this three SDG goals, that is Sustainable Development Goals, that is 7, 9, and 13. And I will share you one topic also, improving transport aircraft emission using machine learning approaches. So before proceeding further about this, deep into this, what is machine learning? What are the applications that we go further? So let me give you my journey. So I have my own startup and company in India. So I have started my journey in the year 2017 by inaugurating aerospace center. Then, as you can see, in 2018 and 19, we have also achieved a Guinness World Record, and we have given and delivered several lectures, and we have been also a part of keynote speaker and across India. And 2020, I have been awarded as an Kalpana Chawla Award. And currently in 2024, in our research center, we have developed a small space museum, and in India, we are the one who is working on AI ML in aerospace sectors. So this is a basic layout what Innova World Research Center is doing. Now, apart from that, let's focus today's session as we are going to discuss here more about sustainable development and how we can, proceed further, work together across the country. So the first and foremost motivation that comes from five core sectors and five core programs, where many of you might be aware of this program, that Clean Sky 2 program. Then we have a EU Horizon Garden program, iCow program, especially in India, and iCow is already available across the globe. So these people and this program, what they do, they always trigger to do something better for the aviation sectors, aerospace, or the space industry. So the main motto is how they can reduce the carbon footprints. As we know that when we are launching a single vehicle, every time some amount of carbon footprints we leave behind. So how can we sit together and do more R&D work, and how we can reduce that carbon emissions? So as you can see, the what's future. So as many of you might be aware of it, that what are the revolutionaries technologies and what are the evolutionary technologies. And currently you can see from 2030s, the more engines going to come. And because as you know, we are our here the main focus is to reduce the carbon emissions. And in 2050s, the scenario is going to completely different. As of now, we are seeing Airbus 350 flights nowadays, but in future that also going to get obsoleted, and going to see double bubble aircraft, where NASA is working on this kind of projects, and more on to this blended wing body aircraft, where around 50% of carbon emissions and fuel burn is going to get reduced. Now, how to get reduce it, and I will give you some basic overview. So before getting started, as this session is primarily focused on machine learning and AI, let me just give you a brief. What is AI? Maybe there are some audience, they're quite new with what is AI. So something when someone is creating, or we can say a human is involved, which is not naturally formed. A human is involved to make such thing, or able to understand that particular thing, that comes as a artificial intelligence. So a human is involved, human is reproducing the existing model. So that is a artificial intelligence. Now how does artificial intelligence differ with the machine learning? So machine learning is a part of artificial intelligence. So what a human is doing, human is doing some programming, they're understanding the parameters, they are rephrasing the parameters, and they're making something and see and checking it, that whether this thing are feasible with one another or not. So as I have said, machine learning is a part of AI, and how we are building it, we are utilizing the different sectors. So in nowadays, we are using machine learning across a different domain. So let's understand what is machine learning. Basically, machine learning of different types. Okay, we have supervised machine learning, unsupervised, semi-supervised, and the reinforcement. These are the prime types of machine learning, and furthermore this machine learning has been clustered in different other domains. Now here I have pointed some of the like very exciting, or most of the approaches or the types of machine learning that are randomly used in the research field, especially in the field of aerospace. Now if you are planning to propel your career towards machine learning, or you are already working on machine learning, so you can take it into granted that these are the following methods are going to consider it. And how I'm telling it, because here are certain research papers where they have some of the exciting things they have mentioned, the methods, the way they have implemented on different application. See, the application of deep learning in a predictive maintenance of aircraft engine. So they have used a deep learning techniques, and in future they have said that how further they can improve it. So each of these different types, there have, each one of it has a different now way of approach. And they have given a future insights on how we can furthermore improve it and bring back to an better accuracy. So understanding this facts, so here I'm going to give you a basic 10 fundamentals outline that where and how we can use AI and machine learning in aerospace and defense sector. The first and foremost that I'm going to highlight here is an aircraft design and manufacturing sector. So, how we can use here in aircraft design and manufacturing sector, especially in the optimizing design, digital twins, and additive manufacturing. But if I have to expand that idea behind this aircraft design and manufacturing, inside that aircraft design we have further more classifications, because when we say a word, simple word aircraft design, it's not that simple as it looks like. It's there is so many things are involved with this aircraft design. There comes development, testing, operation, and once you have manufactured it, so pre-flight inspection, post-flight inspection, and to check the safety compliances, then pilot assistant, co-piloting, then comes to marketing. There's so many things, maintenance. There are list ahead of me, but if I have to highlight about, yeah, so it's a predictive maintenance. What is it? That how to fault detection. You have an engine, and how will you predict the engine, everything is fine with it, because there are so many complex design and the systems for an engine. So you use AI, so or you use sensors, so that something you are building, so that if anything goes wrong you can find it. Nowadays, in fact, in industries, they are started to use this practice, detecting faults. So there is a pipeline in the industry or a boiler. If the temperature exceeds beyond certain level, they can able to predict that. So there are a lot of R&D things that is happening in this fault detection. Then comes in health monitoring. Yes, this fault detection is one side, health monitoring. So this health monitoring is also play a vital role. Nowadays what is happening, they are utilizing is for agricultural sectors. Like you have a drone, and the drone what is doing, imagine you have a apple farm, okay, or any kind of farm you have, and that is meant for it is loitering across the farm. You have made all sort of path planning and all, so it is finding the which particular tree is not healthy or the fruits are not healthy, so it is predicting you and giving you some beep sound, okay, ta, 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 and accordingly you can identify which is wrong, right? Accordingly you can do a lot of activities. Now you have an aircraft, and they will give you a scheduling of it. So okay, this aircraft has been gone for this, now it is time for b check A, check B, check C, and check D. So a lot of things can be utilized using the predictive maintenance. So it's a very very wide scope if anyone is propelling their career or want to start your own startup company also. Next is an air traffic control management. As you know, there are certain busy airports are there. Like every time nowadays, we can find the airports in the queue in the runway or the taxiing zone. So for them nowadays, they are implementing in their portal like flight scheduling optimizations, collision avoidance systems, and effective airspace utilization. So how effectively they can utilize it, the space that they have it depends on the country to country, how their each the governing rules are applying for it. Okay, so yeah, next comes aerospace research and space exploration. So as many of you might be knowing, as I have given a basics of outline that this how we basically the main motto of this talk is sustainable development, how we can do it using AI and ML. So as you know, satellite, yes, we are launching a rocket, we are launching a satellite, that's fine, but how we can make it a more effective one. So satellite operations, so imagine from India we are sending one satellite, from West African we are sending one satellite. So how can we say it's all a revolving across the earth, right? So how we can avoid a collision over there, how effectively we can change the track of it. So everything comes under AI and ML, and there is a collaboration, there is a coordination between the countries, and we are playing it. Same for
How come
space.
this the way they sound now?
Yeah. Any question?
This guy no option. Oh, Tata. Let's go and move on. The thing goes
Yeah,
there.
yeah. Okay, fine.
But now it's like-
So planetary explorations, space shuttle autonomy. So all this very vital role. And top of that, talking about this particular topic, as you know, in this year, in World Space Week, when we celebrate from 4th October to 10th of October, so that time, this title was also like space and climate action. So many of you might be aware of it, how actually the AI/ML play a vital role in climate change. Now, so already this is a very good practice that has already been incorporated across the globe. That is a pilot assistance and training program. So AI co-pilots and flight simulators. So if and there are a lot of things that we can incorporate in this particular sector. As you know, the previously what we used to have, if anyone want to be a pilot, they just need to get a training, that flight simulator training. Okay, they should be well versed in at that. So nowadays what is happening, when the pilot is start ignite their engine, right? So they will have everything's are digitalized, they will have everything, all the instructions are coming to that digital panel. Okay, now once engine started, they don't need to carry any practical manual. Even there are some faulty things happening when they're in flight or post flight or pre-flight checks, those manuals are also been available over there. So these are excellent, this AI and ML are doing an excellent job on that. And also nowadays they're also involving an health monitoring system. As you know, suppose you are flying from one point to another point, and imagine you're a pilot and flying from one point to another point. So many of the scenario we have seen, no, failures of engine or failures of control surface. So this kind of monitoring system or the assistance using AI and ML can save a passenger's life. So it's a lot of things that comes into the picture of AI and ML in aerospace. Now, many of the country already they have started this work using AI/ML, supply chain and logistics. So when they are into inventory or the supply chain resilience, so a lot of things they can do. They can plan where the inventory sectors, how they can transport from one point to another point. So AI play a very vital role, and most of the defense sectors they already into a practice when it comes to a defense sector for its supply chain and logistic. Next, as I have said, this environmental impact reduction, how AI/ML helps. So I will give you a small practical demonstration also. That one of my research that I have worked, I will just give you the highlights, how actually using AI/ML you can reduce the environmental impacts reduction. So how it has a very vital role, One is a fuel efficiency and optimization. One is the eco-friendly aircraft design. Nowadays, as you might be aware of, there are different aircrafts coming up. We have electric vehicle aircraft that Airbus is already going to, manufacture it in 2050s, and there are a lot of aircrafts that are going to come into the picture in coming years. So all they are working on AI and ML. So when it comes to aircraft design or to save fuel or reduce an carbon footprints. Yes, security and surveillance, which is a quite relevant with the monitoring system and the cyber security. So both again play a very very vital role when it comes to AI and ML. Right. Now, let me highlight one more important point about it is that a human factor and passenger experience. So, yes, you might be thinking, okay, humans are only involved in AI and ML. So, how can we give a human factor and the passenger experience? Yes, it's play a very, very vital role when it comes to any airlines. How? Because to run any airlines, the first and foremost priority of any airlines is to take care of the ergonomics of the flight. That means that human comforts and the passenger comforts. Imagine you have an aircraft and you don't provide any sort of passenger comforts. Do you think that passengers will pay a single penny and take a flight of yours? No, of course not. So what are the facilities that you are providing? And I will upcoming slides I will also highlight some of the wonderful R&D that is currently happening, and what is going to what upcoming 2050s, what are the current trends, how the things are going to be there, right? Yeah. Now, coming back to, as I have said, that I'm going to focus on some of the practicals. So let me give you one more highlights for a new aircraft design. As I have said, we need to understand the market trends and to improve the profitability. And as I have also highlighted when I was discussing the human comforts, yes, you should take care of cabin environment and quality services and ambience that you are providing. Now let me tell you or connect you how it play a very vital role in the socio-economical concerns, right? So one of the current trend that a concept came up is a retrofit. So what it says that a reduced emission of transport aircraft operations by fleet-wise implementation of new technology. So this particular word explains a lot. Okay, and you will be surprised to know that human the this how the quality service play a very vital role in terms of performance, environmental impacts, and the economical measures. When it comes other side, it's a carbon footprints, emissions, and fuel consumptions. They are quite related with one another. Now, in this particular slide, I'll be giving you a brief overview that how aerodynamics, systems, and cabin environment play a very, very vital role reducing the emission, that means carbon footprints, and also to improve fuel burn. So, as many of you are from aerospace background, we are quite aware of it, how fuel burn reduction can help a lot in carbon reduction. So, as you can see, some of the technologies that I've highlighted in terms of aerodynamics, in terms of cabin, and some of the system, right? So, this all are comes under the retrofit. So, which helps to reduce emission. And the same time, let me give you some statistical value that what is a percentage that helps to reduction. So just imagine you are developing being an aircraft design engineer, and you are developing a aircraft, and you are incorporating almost the last this three. Okay, you're using winglets, you're using lightweight cabin, you're using taxi boat, and also incorporating structural health monitoring system. This four. So just see the maximum percentage, how much amount of fuel reduction you can make it. So this is just an individual one. So when you gross it all together, around close to 20% of the fuel reduction you can opt for. Now let me give you some of the another highlights. Who are the people who are really working on it? That when it comes to an emission, so emission basically emits not only from the design that you make, engine play also a vital role. So what are the prime engines that upcoming era we can see? That is advanced and ultra fan engines. Another one is an ultra high bypass ratio turbofans, which this bypass ratio is going to be more than 10, right? Second is that aircraft system. As you can see that how much amount during the taxiing phase. Actually, if we are using an electric taxiing, and there is a company called Saffron, they are developing this concept. So around 51 percentage of nitrogen, 61 percentage of carbon dioxide, hydrocarbon around 62%, and carbon monoxide around 73%, we can reduce it. And during this process it takes hardly 3 to 6 minutes to perform this. In this 3 to 6 minutes, this much amount of carbon emission can be reduced. It's a lot of revolutions that you can say. Right. Now, here I will give you a brief of some more research papers that they're working on AI and ML, and what is a basic approach to undergo the machine learning. I will give you just an overview of my research, how actually I have reduced a lot, and how to find out the robustness of your model, and how actually you can implement in the real world scenario. Okay, so basically, when you want to start a machine learning, the first and foremost thing that you require is a data collections. So, or what are the when you're collecting data, what are the different parameters that you have? So, for an example, I will show you this data. So, as you are all aware of this aircraft models, A300 or Boeing 787, either of it. So, all are aware of this aircraft models. So, this is my data collections. All right. So, in this data, as you can see, there are different nomenclatures that has been mentioned. And now the question comes, how will you know this data that you have taken is sufficient, or the data which you have taken, the number of rows, number of columns, or do you need any other parameters? The basic understanding is that first is the data collection. That has you need a large amount of data set when you want to work on the machine learning approach. So first, data collection. So the parameters that you have taken, you must understand how this is important, the parameter that you're obtaining. So here my main concern is to understand or find out the emission, how of this parameter, the engine, the thrust, when we have a configuration of the aircraft, how it play a vital role in the emission factor. So as you can see, there are three concerns I have shown. I have collected the data based on real-time MOM aircraft. So basically, let me give you an overview of MOM. So Boeing in the 2005, they have mentioned a concept called middle of the market aircraft. Okay, so what is a middle of the market aircraft? So Boeing has proposed this concept because they found that if the passenger ranges between this around 180 to 280 passengers, so that it is a ideal passengers where those aircraft and those airlines, those who are purchasing this, will be having the highest profit. So that is what the Boeing proposed this in the year 2005, and from there this concept came as a middle of the market aircraft. In short, we called as MOM aircraft. Okay, so the data has been collected from there, and it has been segregated in three other parameters, understanding what are the different types of MOM aircraft, and how much amount of emission they're producing. Because if I see a gross of MOM aircraft, so all may not be from traveling in India or traveling abroad and different sectors. So how they are very play a very vital role. So after that, how I proceeded with the modeling and robust, I'll be showing you in the upcoming slides. So first and foremost thing when you're proceeding is to identify their correlation factors. So that is how we can mathematically find. Here I have used a linear regression method. So in a linear regression method, we identify the parameter using the value, what's the value ranging between 0 to 1. If it is 1, close to the 1, so that parameter is strongly connected. If it is less than 0.5, means very very less than the moderate value. And here you can see the parameters which I have obtained, which is very close to 1, that is 0 0.5, 0 0.6, 0.8 and 0.7, close to that. So understanding these parameters and how these are playing a very vital role in engine technologies. There are different types of technologies. Each engine has their own technology and the implementations, right? And understanding the number of aircraft traveling from India to abroad, because this is a statistical data I have obtained, the aviation emissions especially in India. So what are the domestic flights flying within India, from India to other countries? So likewise it goes on, like there are different sets of notations that has been given over here. So understanding the key parameters. So furthermore, we have also collected the engine datas and other things and all. So let me show you the final thing. So after that, I have obtained a different cases. I have used regression methods on those parameters using. There are a lot of softwares that you can use. They can use MATLAB. You can use Python, Anaconda, Jupyter Notebooks. There are a lot of no options you have wherever you want. You're comfortable. You can work on those. And see, I have taken 6 different cases to understand the robustness of their parameters. And then finally have obtained a very novel solution where it will shows if you are making a different aircraft, and if you're utilizing this particular and if you're utilizing this particular equation, so you can obtain a very suitable answer. So you can also obtain what will be your aircraft's emission model. So there are a lot of benefits if you're using, in fact there is one of the sector where you have, ICAO, that is a carbon offsetting reduction scheme for international aviations. They play a very vital role. They fund you, they provide different grants and all. So I hope I have given you the lot of overviews about the AIML, especially in aviation and aerospace.
Yeah, you can do. I will
Yeah.
work like this.
Yeah, thank you so much. Thank you. And now you have any questions, so I'm good to go with that.
Okay, thank you,
So
Dr.
I'm waiting for the question.
Thank you. Please, if you have question, kindly drop it inside in the chat section. If you have question, kindly drop in the chat section. Or you can signify by raising up your hand. Okay. Thank you, ma'am. It's such a wonderful presentation.
Thank you so much.
Thank you. Thank you. Thank you.
Yeah. I hope we don't have any question.
Okay,
Yeah, we have
yes.
some.
Sure. You will get the recording after the whole program. The recording will be available. Okay.
And if anyone want to collaborate with us, do a lot of AI/ML research with us, we'll be happy to help them also. So we
All
can
right.
internationally, we can work together.
All right. Someone have a question in the chat section. You say, I want to ask, ma, how do you
Yeah,
get a
yeah.
large data set to use? How do
Right.
you get?
So yeah, how do you get a large data set? It is up to you. The Kaggle. In the Kaggle, you can get a lot of data, and still you don't get it. The example which I have shown you, I have used a different manufacturing company of an aircraft manufacturing company, and I have extracted the data from there. So it's a really a lot of it's a time consuming, you can say. So it's up to you. There are open sources are there, but make sure of that you get right data. The data is authentic from where you're getting it. That is, I hope I have clarified your doubt. Yeah. Yeah. Any other question?
Is there anyone that have any other question to ask? Okay, thank you, thank you, Doctor. Really appreciate your presence. Since there's no
Thank you
other,
so much. And all the best for the rest of the events that you're conducting. And you guys are doing an excellent job. All the best.
thank you.
Yeah, thank you. So, can I leave the session?
Yes, you can.
Yeah, thank you. Stay
Okay.
connected. Yeah.
Okay, welcome everyone to International Space Technology Convention. My name is Marvelous Olatunji. I'm the founder of MARVECX and also the convener of this convention. So as we are continuing with the program, we have a, let me say, 10-minute break before we proceed with next section. Thank you.
usually use is for 3D modeling, I use SolidWorks, and for the texturing and rendering, I use Blender. Mainly, my work mainly focus on these two tools. Okay, I quickly share with you this slide, an application of the use of 3D tools to be able to develop a prototype, okay? Apply it to the aerospace sector. In this case, you can see two images, yes, two pictures. In the left picture, you can see conceptualization of a deployable solar panel, okay? This is how I can implement my tools and get this or bring this idea from my mind to the PC, and I can represent in this way. And in the right side, you can see, so using other technologies, like for in this example, a 3D print, we can develop a really prototype, functional prototype, okay? The use of 3D tools allow us to represent products or physical elements in an accurate way, okay? To have a global vision of what they will be like. So it's important to highlight that 3D modeling must be done with a series of parameters and measures, yes? So that the digital representation is proportional to the physical. So it's important to take that into account. The 3D modeling allow us to interact in several professions and make a collaborative work in real time, okay? Now, I think that the best way to show you the use of 3D tools is by applying a practical example, okay? So let's look in this way. For example, a CubeSat, like I show in this presentation, okay, is developed. So now that it's built and functional, the question is what is the next step? What need to do? What I need to do? So we are going to do a practical exercise on how we could implement 3D tools in the development of a prototype, in this case, to launch the CubeSat in the orbit. So basically, we can imagine that we are a developing of a CubeSat deployer, okay? For the development of a product, we have several ways to do it. So in my opinion, we can break down in 4 stages, basically 4 steps, okay? The first step is identifying the need, okay? The second stage is regulatory research. The third step is the product specification. And the fourth step is the engineering design. So identifying the need, we need to understand the problem. For this particular exercise, we understand that we need to put the CubeSat in orbit. So we can say that this is our main goal. This is our main objective. Like any product or mechanism, it will have a critical role in the mission, since if it doesn't work, obviously the mission will not be successful. Therefore, precision and safety must be needed, okay, for the mechanisms to work. For this particular case, our output will be a reliable mechanisms that work in orbit. Then we have a research for source that guide us in our design. Generally, we go to organizations such as ESA, ECSS, NASA, which give us general guidelines, okay, in which we can base ourselves to develop our product. In this case, the deployer. Safety protocols must be met because the prototype must be designed to be able and be safely handled in the ground when it is transported, avoiding damage during the transfer process, okay? It's important to know to take into account that the compatibility with the rockets where the deployer is going to be installed, since each company has its own regulation and standards. The product specification, at this point, we are ready to touch on topics such as geometry or any other possible elements to use. The size compatibility will be a key, since we can orient the designs. For example, we can design it for 1U, geometry 2U, 3U, 6U, 12U. Everything will depend on the specific needs of the mission. Materials and dimensions in the aerospace sector, space is limited, so limited. So making a compact and functional design is vital. We have certain factors that will have not or more weight than others. In this particular case, for example, we can say that ejection speed is a performance factor. So we enter in the phase where the 3D tools will be used. Generally, when the prototype is developed, there will be many ideas for the possible solutions. So each one must be evaluated in order to select the appropriate. So we begin to make a handmade drawing as well as simple 3D models of a possible mechanisms. Here, we don't go too much in details. Rather, we use a basic geometric shapes, for example, cubes, rectangles, cylinders, in order to visualize our prototype, how we are designing the prototype. It's important to take into account that components and costs, since in startups, the issue of money is sometimes limited, okay? So we seek to develop a functional solution with the least possible expense. Another point to take into account are the possible failure modes of the system or of the elements that compose it. So we can evaluate the buckling or shearing in the screws. Now we are going a little deeper in the use of 3D tools. We begin, in this example, by developing of analysis of the mechanisms. In this case, in the mathematical basis that allow us to size the element of the system. It's important to note that the design phase is iterative. We will always calculate and recalculate several times. In these times of situation, we can use a spreadsheet to simplify this. It is a iterative process because we can evaluate, for example, with several tables, key factors of the design of a specific element. For example, in this case, I show the possible way or possible solution in the sizing of the spring in the mechanisms. Okay, we previously discussed that the use of 3D tools allow us to represent in an accurate way any product or physical element, okay? Even without having to build it. In this particular case, we can anticipate the details that will be given when the prototype is built or will be built. For example, the use of bolt joints and the location of each screw in the final assembly. Taking into account, for example, the geometry of the threads of each screw. Another application of 3D tools is to anticipate the assembly process of the prototype, such as the space available in the prototypes to use the tools for its assembly. The space that the operator will have to use for example, the screwdriver to tighten the screw, as well as the space available for the hands in the assembly process. Okay? Generally, the 3D tools modeling programs have additional features which allow, for example, perform finite element analysis, which can be used to see the possible behavior of a part under allowed state and be able to anticipate possible failures. Using 3D tools, we can also simulate the movement of the mechanisms and its possible behavior. In this case, for example, we can study what the expected ejection speed will be, okay, iterating with certain configuration of the mechanisms. This allows us to take into account where the component geometries fulfill the expected functions. Okay, like we can make some iteration using, for example, the length or the diameter of the speed, sorry, of the spring, and we can calculate the speed of ejection. In this case, it's iterative. All this is iterative. Finally, we arrive an expected solution. In this example, we can have several results, which will vary according to the needs of the mission. In this sense, in this example, I show you two possible results: the use of 3U and 12U deployer. It's important to know that once the 3D design phase is finished, the prototyping phase begins, okay? I think that this could easily be a subject for another presentation since the new challenge and problem arise, okay? Now, it's important to think that the mechanisms does not work by itself, okay? Controllers, actuators, sensors are needed, and all of this allows for working hand in hand with other departments. Multidisciplinary works, as an example, show that PCB that can be developed to control the actuators and receive the signal for the sensors. Taking into account the space available in the mechanisms, we can design a specific component for this application. In this case, I show you example of a development using some size, okay? I don't know if you can see these measures, okay? But we can start with a very close space. Yes, we can give a shape, in this case, a square shape. And, for example, participate with the hardware guy or electronic guy, if we can develop a suitable application for this space. Yes, the PCB is designed over that space, and we can create a specific PCB for that application. Okay, for the moment, we went through practical examples of the implementation of 3D tools. To recap quickly, we started with a challenge that required a development of a mechanism which will put the CubeSat into orbit. We divide the process into a series of stages where mathematical engineering principles were applied, which allow to us develop a product. We can say that a structured process is important to achieve this goal, okay? The solution in this talk was the implementation of 3D tools to be able to create technology for aerospace application. Okay, I think that this is all for the moment. Thanks for the attention. If you have any comment or question, you can do it, or you can use the chat.
So you're welcome, sir. Thank you. Please, if you have any question, can you kindly drop in the chat section?
Okay, I see in the chat, very interesting. Thank you so much. Do you have plans to test this in the, let me check. I lost the chat, sorry, let me check, okay. Plan for testing this technology in space directly? For the moment, not, because we need a lot of money, okay? So, but in the future, if we can, or if we have the opportunity, of course. Okay, any other question?
Okay, and I have a question, sir. So my question is that And is there any particular system, type of system that can be used to design the prototype?
A particular system. Well, for this application, okay, there are a lot of solutions. We can use a Spring. We can use a compressed air. But basically, in this kind of solutions, if the solution is practical, it's better because you don't need more problems. For example, you can use, for example, a compressed air to push outside the CubeSat, but compressed air need a compressor, need a lines, need a pipes, so it's more complex, okay? You can use, for example, electronic actuators, but you need electricity, you need batteries, you need controls. It's complicated. Sometimes the more simple solution is the better. In this case, for example, or the main developed path for this kind of solution in the case of deployer is the use of compression spring, yes, because it's the most reliable solution.
All right. Please, I also have another question, and I don't know, how many years does it take to learn how to do a 3D modeling of a design? Like to learn to become perfect. For example, you say you make use of SolidWorks, you make use of Blender, and other software like that. So how many years does it take for one to learn such and to design with such tools?
Well, time we can, for example, if you are a beginner, if you practice all days and make some practical exercises, not necessary in the aerospace sector, only the basic things, maybe 1 year, follow with the tutorial or this kind of tools that you can find in the online, YouTube, for example. But I think that 1 year, if you put all your effort in that, 1 year is enough. I see a question in the chat. What's the percentage efficiency of the models under test? Efficiency of model under test. Well, this was a practical examples. This is not built in this moment.
Sorry. In addition to that question that the person asked, I think there are some software that is being used for carry out and computational and testing on such modeling. For example, now we have ANSYS. We have ANSYS that we use for simulation of the design. I don't know if you make use of ANSYS also. I think there are some software that can be used to check the model after it being designed. I don't know.
Simulation, do you need, do you mean simulations because I showed some slides, yes? I showed the simulation of movement and I showed the simulation for element analysis, finite element analysis. I don't know if you are question about it.
Oh, Grace, not actually. I don't have a question about it. Actually, I don't know if you have any one of your design that you did with Blender. I don't know if you can show it to us. Thank you.
Show my designs, previous designs.
All right, thank you, sir. It's such wonderful to have you here. So I think Princess will take over. Princess, are you there?
Okay, thank you so much for the
excellent
invitation.
presentation. Thank you so much for joining us at this ISTC. All right. So Bika, she's already here. She's already here. So let's meet Dr. Srimanti Kisan. She's the founder and CEO of Space Kids India. Dr. Kisan is the visionary founder and CEO of Space Kids India, mission director for
Shakti Sat.
She has created space awareness program for over 1 million children across the globe. Dr. Kisan is also one of the few women to have experienced zero gravity firsthand. So, where she shares her valuable insights.
Hey everybody, hi, good afternoon, good evening. I hope you all had a great session. The previous session was very good. I was listening to him and it was very good. And 3D printing, yes, of course, it's the latest thing. And there are so many things that the entire world is looking towards additive manufacturing. So I was so happy that he made a great presentation. Well, with regards to me, I'm a space entrepreneur and the only Indian woman founder to have launched about 27 space missions in India. And probably more than me talking, I will share a video so that, you all can understand our journey, at least about 2 years ago, because after the video, we also launched the latest, we launched the latest satellite that went up on 16th of August. So do I have the permission to share the video? Can you give me the access?
Yes, you can. You can share your screen now.
Thank you.
कलाम सेट लॉन्च किया गया।
Kalam sat, and they are the first customers. Let me compliment and congratulate the team.
நம்ம சூரிய குடும்பத்துக்குன்னு ஒரு வரையறை இருக்கு, ஒரு எல்லை இருக்கு. அந்த எல்லையை தாண்டி நுழைவோம். அந்த பால்வழி பேரடைக்கும் ஒரு எல்லை இருக்கு. அதை தாண்டி வெளியில வரும்போது அது பக்கத்திலேயே ஆண்ட்ரோமேடா கேலக்சின்னு சொல்லி ஏகப்பட்ட பேரடைகள் இருக்கு. இது எல்லாத்தையுமே ஒன்று சேர்த்தது தான் சூப்பர் கிளஸ்டர்.
So hi everybody, thank you so much for watching that. Thank you so much for watching our journey patiently. So now we've built about 27 space missions, and this was our last one that we built. It's an 8U satellite, which was built by 750 rural girl children of India from Kashmir to Kanyakumari. That's the north to the south, east to the west. So all the states were involved, and we built this satellite. And this was a communication satellite. And now moving forward, we are building a spacecraft to the moon. So we want to inject this in lunar orbit, and this would be a 2026 mission where we are going to be involving about 108 countries. It's not only India, because we feel that space education needs to be spread across the world, and the countries that do not have space education, we want to give them, and it's all going to be for high school students. We've onboarded about 60 countries. We are looking forward for 40 more countries to be onboarded, and we will start imparting this education online. And subsequently, we will be choosing one student from each country to come to India to build a spacecraft hands-on. So this is the mission we have embarked on, and we are extremely happy that we are doing this far and wide. It's going to be a historic mission. Well, what would this satellite do? Yes, it's going to be in the orbit, and most probably we are working on the mission planning. So the mission planning is going to be in progress for another 1 or 2 months till we identify and finally freeze what we are going to be doing. So that about I think it's more because we hardly have about 3 or 4 or 5 people here. So if you have questions, we can actually do an interactive session rather than me just going blah blah blah. So thank you, Marvelous. I call him Sun. Thank you so much, Sun, for organizing this beautiful conference and making me a part of it. Thank you very much.
Thank you, ma'am. I really appreciate that. Thank you. Thank you for your support throughout the program. I really appreciate it. Thank you. Thank you.
God bless you. You're doing incredible. So I truly feel so happy.
Thank you, ma'am. Thank you, ma'am. Thank you, ma'am. I really appreciate it, ma'am.
So if there is any question, we will do the question. Or else I think we are delayed. The next speaker can speak.
If you have any question, can you drop it in the chat section? If you have any question, can you drop it in the chat section? Thank you. Or you can signify by raising up your hand using an emoji.
No, I understood what we are doing. So thank you so much. See you all tomorrow on the panel.
Yes. Yeah. We love it tomorrow by God grace on for panel discussion. Okay.
Thank you, Robert.
Yeah. I have a question.
Thank you so much.
I have a question.
Go ahead, Sam.
Okay, and my question is that, and as regarding your project, because based on your biography and based on the little research I've made about you, I got to understand that you've carried out a lot of projects So my question now is that how do you get fundings for most of your projects? How do you get
Well, funding is
your projects?
real issue. Industry, yeah, space industry. People don't still. There are a lot of VCs coming in. If you have a good project proposal, then you can actually raise funds through VCs. That's what my team of technologists are looking forward and building a new company called the Catalyx, wherein they have been chosen as the for the accelerator program. So I'll be very happy if you can look at CDL is one, and Y Combinator is one, and the other one is this is accelerator program. Techstars for aerospace industry. So if you're able to look at, they will handhold you. If you just need to have an idea, make a nice issue, and they will handhold you and get your project approved and put it for VCs, and you will get the fund to work on it.
All right, ma'am. Thank you, ma'am. Thank you for the answer. Okay, I think Mr. Rave is saying something. I don't know, Mr. Rave, can you unmute yourself?
Didn't get you, son?
No, Mr. Rave is saying something. I don't know. Can you unmute yourself, Mr. Rave, and ask your question?
Share your contact, spacekidsindia@gmail.com. Okay, let me do that. Okay, thank you. Take care, all of you. Bye.
Okay, thank you for joining us today, ma'am. Really appreciate your time. Thank you, ma'am. Thank you, ma'am.
Thank you, son.
Yeah.
Thank you so much.
So once again, everyone, thank you for joining us. Thank you for joining us today. Really appreciate your time. Really appreciate your time. Really appreciate your time. The next guest speaker is currently not available. I don't know when she will be around. She's supposed to come in by 12. It's not in my plan. It's not in our plan that Dr. Kezna will always spend a little time. Same thing goes to Robert. Yeah, Robert always spend a little time. No, yeah. Oh, sorry, Juice rather spend a little time. So the time which make the program to kind of, when you plan to make use of 1 hour and program is not later, the later spend, let me say 20 minutes, which caused the program to kind of be fast. So the assigned time given to the next guest speakers is sorry, let me check. Sorry. Dr. Clary Nelson is 12 p.m. watts, and this 11:36 a.m. watts, which means we still have like 24 minutes before she will be around to join us for the meeting. So in the process, maybe we have a short break before she will be around. Let me say in 24 minutes time, we'll continue the program if she joins us, and if she did not join us, which means we go for the next section of the program. Thanks for joining us once again. It's such a nice to have you all here. Thank you. Okay, meet Dr. Claire Nelson. She is the Chief Ideation Officer of the Future Forum, recognized as the Forbes Top 50 Futurists, Global Goodwill Ambassador for UN International Moon Day, an author of Smart Future for a Flourishing World. She's also the founder and the president of the leading diaspora think tank, the Institute of Caribbean Study in Washington, D.C., where she has made a significant contribution to the development and innovation for small island developing states, SIDS. Thank you for joining us, ma'am, Dr. Kainezi. So you can continue, ma'am.
Thank you so much. Good morning or good afternoon or good evening, depending on where in the world you are. This is an opportunity to have a conversation about what sustainability might look like when we think about it from the perspective of what we're doing in space. I would like to talk about my work as the first Jamaican on the moon and talk about how I first got to the moon in 2034. I went up to the moon in 2034 to help set up the Kijiji Kilimia, which is a people's village, a project that I began back in 2016 with a vision that the moon and lunar settlement should be democratized. And I want to pause there and say I already have taken a leap in the future. If you notice, I said I went up to the moon in 2034. I already positioned myself in the future, because when you think about the process of sustainability and innovation, what we're actually doing is innovating for some future we like to see. My work in space is really to see how we might bring the non-spacefaring countries, the developing countries which don't have a space agency, or if they have just a fledgling of a space agency, or if they haven't even thought about having a space agency, to the table, and to bring peoples and scientists and engineers and artists and the whole community of humankind from those countries to the table to ensure that our future as spacefaring civilization will be one which is one that reflects the desires of not just a few people, because it is my contention that space is one of the global commons, just as the future is one of the global commons. When I used to say that before, people didn't really agree with that construct, but most recently, the UN had a Summit of the Future in September of this year, where I think for the first time, most people in the world, or most government and policymakers and NGOs that dabble in multilateralism, came to the agreement that if humans did not self-correct, if we did not do what we needed to do differently, we were not going to make it as a species, given that we have the opportunity to self-destruct many times over. And one of the ways in which we have the opportunity to self-destruct is by doing space in such a way as to further destroy the fragile atmosphere that keeps our planet in balance. And I know I've heard it said that there's nothing that we can do as humans to affect the moon or the planet. Well, that's not quite true. We know that humans are having an impact on the moon. And more recently, when you hear of many of the geoengineering experiments being thrown up and bantered about to deal with the issue of climate change and global warming, one shudders to think what one might want to do on the moon in the future. And so for me, it's very important, first of all, we have a mindset shift, that there is indeed a sustainability mindset that is imbued in all of those who are involved in the design process. And to do that, my decision was, how can I get African engineers and researchers and physicists and scientists and artists involved in space research when we don't have a rocket, we don't have a shuttle program, we are barely doing satellites in these developing countries. And so the OASIS, the Omni-Africa Space Exploration Analog Simulation Project was born, OASIS. And OASIS is really the vision to create a network. Hello? Hello? Yeah. OASIS is a vision to create a network of analog space research stations that will allow African engineers and scientists and food technologists, etc., to really play around in designing prototypes and examples of what they think our future as a spacefaring civilization ought to look like. Because after all, we're going to need everything in space. We're going to need the very air we breathe. We're going to need food. We're going to need water. We're going to need shelter. And quite frankly, if we can solve for space, we should also be able to solve for Earth, solve for the SDGs, and deal with some of the challenges that are facing African countries and African people who live in precarious positions. If you're a nomad out there in the desert, in the Kalahari Desert, or in the Chalbi in northern Kenya, you're going to find life very precarious in terms of lack of water or inadequate food sources, etc. How can we then create research programs? Because after all, space is the ultimate hostile environment. We don't have what it takes to survive unless we bring everything with us. And so we talk about then this idea of sustainable innovation. I want to offer some design thinking framework of how you, and I'm not sure how many of you on this program are engineers versus physicists versus computer technologists versus food technologists, but whatever discipline you're in and whatever element of the space continuum that you see yourself participating, whether the space exploration, space settlement, the fact is you're going to have to be always thinking about designing something that's first of all going to sustain your life. That's the most important thing. How do you sustain life? And how do you sustain in a way that is sustainable and doesn't create further damage to either our environment as you escape that environment or the environment in which you're going? And of course, there's a big debate as to whether or not there's an environment on the moon. Of course, the word environment is very generic. It's not that it has to look like our environment. Space has its own environment and ecosystem that we know very little about. We think it's dead and arid and all those things, but we still don't know enough about it to make sweeping statements of what could or could not happen if we were to do things without an abundance of caution. And so the design framework is based on an approach I use and I outline in my book, Smart Futures for a Flourishing World. It's available on Amazon, Smart Futures for a Flourishing World. And the word SMART really is an acronym for a series of questions that the reader is asked to take themselves through as they're designing something that they want. The first thing I probably will do today is focus on the issue of the idea of sustainability, because the essence SMART really is asking you to say, whenever you're designing something, what can I do to ensure that this thing I'm designing is sustainable? And two, how can I ensure that this thing I'm designing really is recognized as a system and part of another system? Because my contention is that everything that we design is part of a system. And everything we design is also itself a system into itself. So really, most of what we're doing, especially in space, are solving complex systems of systems problems. And then how do we deal with the question of sustainability? Very well. So we must also decide what it is we want to sustain. In the case of space, we want to sustain life. We want to sustain our ability to breathe, our ability to have water, our ability to deal with our waste matter. And all of these innovations that we will have to make to provide these things for life on the moon in the case of the lunar experiment, which is pending very soon. We know that in the case of Nigeria, Rwanda, and Angola, I think those 3 African countries already signed the Artemis Accords. And it is my hope to see many of the engineers and scientists from these countries begin to participate in the work that I'm doing at OASIS. And you're welcome to follow up with me on LinkedIn if it's of interest to you. We're certainly looking for more bodies to participate in the research that we're beginning to undertake. But back to the point, we want to look at the metrics of sustainability. So in the case of life on the moon, we would have to have obviously a metric around air quality, right? We need to have a certain metric around water efficiency, water sufficiency, right? It's not just the quality of the water. Do we have sufficient water? And do we have it in a way that we have it when we need it? And so these are some questions and some ideas. You would obviously get into more detail if you're doing an experiment. I just want to give you some guardrails of how it is that one might approach the design question of sustainable innovation. Innovation of itself is saying, let's take what we have, what I know already exists, and let's see how we can make it work differently. It's different from invention, where we're probably looking for something that doesn't exist. Innovations may actually exist, but they've not been used in a particular way before. Or innovation may exist, but have not been used for a particular purpose or used in a particular way, or is repurposed to do something it wasn't purposed for. And that, I think, is a beauty, I think, that Africa certainly, and I believe I'm speaking to many African students, Africa certainly has the capacity to innovate with what already exists. Given that, as we all know, I'm from Jamaica myself, that many of our high schools and our universities are under-resourced. We're not going to have, and so I think my time is about up, but I would just want to say in closing that as we think about this idea of sustainable innovation, a SMART framework where S stands for sustainable systems, M stands for meaningful metrics, A stands for designing with the agents on the system in mind. So who are the people who are going to be using the system? Who are the people who have impact on the system? What are the other things in the system that also are agents in their own right? People forget that animals and insects and plants and rocks even may become a problem in your system. In this case of lunar, it could be the agent might actually be the moon itself is now an agent. R in SMART is the resilience question. How do you design for robust resilience? And T, how do you design using technology in a very transformational way, as well as looking at its teleological impact of the technology, second and third order consequence. And I think as innovators, one of the big questions you must always ask then is, as you design for sustainability, what is going to be the end use of this thing that you are designing? If you're designing an innovation for space, let's talk about, for example, a container to travel from Earth to the moon with something you need. Are you going to design a container that you will need to throw away? Or are you going to design a container that you can reuse as often as necessary? Because after all, you have to bring everything with you to space. And so these are questions which are very important, because we have seen people thinking about, on the way to Mars, we can just jettison our waste. Why would we want to jettison waste in the universe? It's not a question that should be asked. If we're talking about sustainability, we don't want to think of things as waste. We always want to think of things being an end product for some other input. So even waste needs to be seen as an input for something else. And so the circular economy, circular engineering, and regenerative engineering is another term that you might want to think about as you talk about sustainable innovation for space and space exploration and space settlement. So I'll pause there and address any questions if there's time for questions. If not, just let me know what I should do next. Yes, I see a question from somebody named H.
Hi, sorry, yes, I forgot to write my name. It's Husseina.
Hussein. Yes.
Yes. So I wanted to ask, I went to a workshop conference recently, and they were talking about how some people are trying to get space itself as an additional SDG.
Yes.
I wanted to ask what your opinion on that was.
Well, I'm probably part of that movement. So I'm not the driver of it, but I'm part of it for several reasons. Number one, I think we need to bring space into the consciousness of more people, because space exploration is happening, whether the majority of people know about it or not, whether or not the majority of people agree with it or not. And the more we have people weighing in on what it ought to look like, is a more possibility, I believe, that we might actually have safe and sustainable space exploration. And I say that because when I see some of the companies that are being funded as startups to address the climate solution problem, companies that are talking about using sulfur dioxide spraying to block the sun. And I'm saying to myself, how do you know that spraying sulfur dioxide all over the world is not going to do more than block the sun? It could actually damage, plants and all other things. I think that we need to have more people with more diverse minds looking at space and how we approach space, how we settle space, how we provide energy on space from different perspectives. And so for me, I think even if it does not become a SDG, I think just by having a movement, sometimes you begin to change the conversation. And what we need to do is change the conversation that says space is the playground of the very rich and famous. We want to make sure that everybody understands that space is for all. We all see the moon from time immemorial, and I'd like to ensure, from my part, that more people from developing countries are participating in the conversation about how we share space in the future.
Thank you very much. I actually had another question. Sorry, if somebody else has a question.
No, there's nobody.
I don't see any in the chat. Okay.
Yeah, please go ahead. Yes.
So you just mentioned something just now about space not being a playground for the rich and famous, right? So I'm currently doing my master's in space systems engineering, and I actually recently had a meeting with my supervisor, and he was asking me about what I wanted to do in the next 5 years, what do I want to where do I see myself? And to be honest, I don't see myself anywhere. I want to work in the space industry, sure. He was asking this because he wanted to know if I wanted to carry on with a PhD. All of this is to say that he was telling me that his ultimate goal is to make that anybody in the world should be able to build a satellite from wherever they are. So right now in my university, we do CubeSats. It's very known for CubeSats, and they have their own bus system for CubeSats. But it's very hard to integrate with some people's systems in different countries, I don't know, Paraguay or Colombia or Nigeria. So his goal is whatever it is that he's doing, with his students and his lab, is all going to the ultimate goal of anybody anywhere in the world should be able to build a satellite with any materials that they see, basically. So with what you just said about space not being a playground for just the rich and famous, how far do you think that is from my professor's goal of anybody can build a satellite from anywhere to where we are now currently?
Well, I know that some of the organizations that I have been working with and partnering with, so for example, I founded the Caribbean Space Society. This is how I got started actually 6 years ago. And nobody believed it was possible. Of course, I found a few people, as I would say, as far out as I am, to say, okay, they want to try it. So what we did was get three universities, 3 small universities, because the main universities in the Caribbean said, oh, this is a crazy idea, because they don't see it, because they think of a space lab as something very big and you have to have rockets and all this stuff. However, I recognize that in Africa, for example, CubeSats are a good place to start. We all use space daily. Everybody who has a smartphone use space daily, but the average person, including myself, don't have a clue as to how it works, right? So the first thing is, how do we democratize that knowledge? I think every student of physics today, every high school student, I did physics, I loved physics as a child, every high school student of physics should understand how their phone works. It's a simple, basic principle. And so for me, the CubeSat and satellites are the most accessible thing for most people because it's what we are in touch with every day. And a lot of people are working hard to solve that problem by either doing IoT software or doing a software, there's CanSats, there's all kind of PicoSats and all, everybody's doing something to democratize this knowledge. And I think it's very important. I don't know how far away we are from everybody being able to do it. And maybe every single person might be a bit of a stretch. But certainly in every country, we should have a capability of at least one university in every single country should be able to design, operate a satellite. The question will be, would you have the ability to launch it, right? When we don't have the rocket space, we don't have the same attention being paid to rocketry certainly in developing countries, but at least they should be able to understand not just what a satellite is in theory, but there should be at least, I believe, one university in every single country should be able to design, launch, run a satellite, a CubeSat, for the purposes of the data sovereignty of that country. It's very important because otherwise, I believe the whole geopolitical system will be out of whack if you always have to go to other people to buy the information you need to know where your water is, where your minerals are, where your traffic is. This is not, to me, a recipe for a still hostile world. We're not at the stage as a species where we're willing to, what I say, wage a peaceful reality. We're still at a stage where countries are invading other countries. I mean, that in mind, and with the fact that we still have a capitalist mindset in mind, I believe we have to democratize knowledge. And so I believe every single country around the world should have at least one university with the capability to design, manage, and launch. And this is why there's a project I'm also a part of called AFCONSAT, being run out of All Nations University in Ghana. And All Nations was a university in Ghana that launched a CubeSat. And their vision is to create a constellation of CubeSats with African universities. And so we've got to get those universities which are still not, they say they want to do it, but they're afraid to kind of march boldly. And I think we have to really believe, like your professor says, that first of all, it's desirable, and second, that it's possible. And I, for one, think it's possible to have that democratization of knowledge. And it's not only possible, it is desirable to have it as well.
Great, thank you so much. I want to ask, sorry, this is just like based on what you just said, not another like big question. Where can I find the information on the AFCONSAT on All Nations, like trying to participate with collaborate with other universities?
All Nations is online. I'm not sure how much of this they put out there in public, but I'm part of that team as well. So you could feel free to reach out to me if you feel it's something your school might want to become involved in. We're still in the growth phase, quite frankly. So we're not like far enough ahead to say, okay, nobody can join right now. We're still in that growth phase. So feel free to reach out to me on LinkedIn and we can continue the discussion there. As well as, apart from the AFCONSAT, those of you on the call who might be interested in lunar settlements. I think one of the things that we have to work on more assiduously, I mean, we're working through OASIS on things like rovers and robotics and energy questions, right? And those are questions we need certainly in Africa itself. How do we provide healthcare to people who live in distant regions? How do we provide food and water? And those are some of the questions that the Space Analog Station will attempt to solve. But so robotics and AI are going to be very critical. Communications are going to be very critical because that's important for life on Earth as well as life in space. But I do think one of the other problems we need to start looking at is the transportation problem. How are we going to create less energy, what do you call it, a new way of getting to space safely without using nuclear? I personally am terrified of nuclear because I'm like, what if they crash? You know, we could crash back in the sea. We have a problem, right? We kill a lot of things in the sea. How do we do that? And so I think to the extent, I'm of the opinion that to the extent that you might find in Asia or in Africa, some student who has never heard a word, it can't be done. And they're going to be the one who will find a way to do it with magnets or some other force, because there has to be another way for us to get to the moon safely or to Mars safely outside of using nuclear, which as far as we know it now is still not safe if it crashes. So, you know, we have a problem. Yeah. Any other questions? Thank you so much for your questions. I enjoyed the discourse. It was fun.
Thank you for answering them.
Yeah, yes. And where are you?
I'm currently in Japan, but I'm from Nigeria.
You're in Japan. Awesome, awesome. And Japan has been doing such a great work in supporting all of these schools. They were the ones that supported all nations. And I know there's a new program that they're doing now with Cote d'Ivoire and Tanzania. They actually won a competition earlier this year, and they'll be starting their journey.
Sorry to interrupt. Is that the Kibo Cube competition?
Yes, yes.
Okay.
Yes, yes. I want to say thank you to them for that support to Africa and other developing countries. Are there any other questions? Mr. Ayinde, is my time up?
No, I'm still looking if people still have questions to ask. If you have any question, can you drop it in the chat section. Thank you for joining us.
Well, again, everybody, thank you for listening. I think that's it for me. And I don't see any questions. Thanks for the opportunity to share. And again, I just like to let the students listening know. Jiwaji, Tanzania. Tanzania. Habari.
Hello, habari.
Yeah.
So you know Kiswahili also. Little bit. I'm very pleased.
Kidogo.
Hiyo nzuri sana.
Yes,
yes, we are in the race also, you know. We are trying to do many other things also, but this one has caught the government's attention. So we have much more support, you see.
Yes, well, thank you for tuning in. Yes, I was in Kenya last year. We were in Ghana this year. Not sure where we're going to go next year for our space conference. But we do welcome partnerships. But the vision for me is to have university researchers partner more effectively. We don't do that effectively at present. And so we're looking for additional schools who may want to join with the Oasis clan, as I like to call us, that are trying to bring together research. And it really doesn't matter if you're doing, you know, food science or you're doing, you know, healthcare science, because when you look at it, as I said, if we're able to solve for space, we're able to solve for Earth, and looking for a broad cross-section of sciences, because if you can do a settlement where you're able to use, for example, 3D printing to print using local sand around you to print a new way of building a hut, for example, right? Able to afford affordable housing. We're seeing in Africa, for example, a lot of plastic waste in very pristine forests and pristine areas because the clay pots they used to use, they could throw them out and they would disintegrate.
And they are even better than the plastic ones.
Exactly, but unfortunately, plastic is cheap, and so we have a lot of work to do to rewire and re-engineer the design concept so we don't also become the dumping grounds. I mean, already we know a lot of waste is exported to Africa. E-waste is exported. How do we then protect our people against the new diseases and the new, chronic problems that come from having so much waste in our waters, etc., in our soil, in our food.
Great.
We have a lot of work to do. I think using space as an entry point is good because it allows you to, as I said, solve for space
It attracts
and solve
attention.
for Earth. So this idea of sustainable design is critical. And the other thing I'd like to offer is that we would like to see of the Futures Forum, which is my nonprofit. I should say the Futures Forum is a nonprofit 501c3 organization. I founded. I'm an engineer by training. And I want to see more engineering schools in Africa also begin to teach sustainability as a design principle for all engineers. And that's part of the principle. We want to ensure that nobody graduates from engineering school. By the year 2030, every engineering school should have a required course that has sustainability design principles in it. How do we get there? I don't know. I'm trying to insert myself in the African Association for Engineering Education to see if we can use that as an entry point. But we have to really move rapidly if we're not to decimate the qualities and leap over the challenge of industrialization. We don't want to go to the dirty part of industrialization. We want to avoid it. So we really need to have some really, I would say, innovation happening on the ground and give room for that. And I think
one example which we have directly is that Africa is so dark in skies. So we have to protect that, I mean, when people just put up lights uncontrollably, people don't understand lights can be harmful also, and to human beings itself also.
Exactly. So we want to have, for example, we should see more dark sky parks being officially named in Africa. How can we work with you, for example, in Tanzania to make that the case?
And the official part should be automatic almost. It's guaranteed that they are dark. There is nothing for hundreds of kilometers, We should not have to go through all the processes that the West has to go through, So we have to be recognized ourselves, and we have to, by the world, and ourselves we have to recognize.
Exactly.
I'm very pleased, for your optimistic.
I hope we can be in touch.
Can you please share your email, please, with us so that we can?
I put it on here. Yeah.
Please, thank you.
Okay, thank you. Thank you, ma'am, doctor. So if you have any other question, you can put it in the section. If you are interested in what doctor is doing, you can connect with her on LinkedIn. So she's such a wonderful person who contribute to the DSG goals. All right. Thank you, ma'am. Thank you for your time, ma'am. Really appreciate it, all right, ma'am. I think you are done, ma'am. Hello, can you hear me? Hello, can you hear me? All right. Thank you for joining us today. Really appreciate your time. So without wishing much of our time, we will move to the next speaker of today, which will be the last speaker for today. Before I introduce him, tomorrow is the last day of our convention. Tomorrow we'll be doing a panel discussion whereby all the guest speakers that was focused in this beginning of this convention we come together to discuss on the theme of the convention. That's harnessing cutting-edge technology for the sustainable development of space exploration. So as we are continuing with today's section, our next guest speaker is I'm coming. Let me check if it's online. Okay, Captain, I'm coming. I want to share my screen. All right. Our next guest speaker is Mr. Aluvala Katin. I hope I got his name right. So before he come up, we can read his biography. All right. Okay. Hope you can hear me, please. Yes. Okay, Alvala Katin Cham leads the development of electronics and software for space application at Space Rickshaw, a clean satellite and entry vehicle. He has built a computer for over 10 space missions, including the high altitude balloon and satellite such as SDSat, ASADSat 1 and 2, SRO, and SR2, as well as the payload for Skyroot Vikram S rockets. Katan also spearheaded the development of the Spencer for the world lightest CubeSat deployer, which win the India Defense Contract IDES, a vanish of young scientists in their training system. He has shared his expertise at TEDx, NASCOM, and IIFC. So we invite Mr. Katan to start his section.
Am I audible?
Yes, you are.
Yes, yes. Hello, everyone. So yes, this is Kirtan from Space Rickshaw. I'm the Vice President of Avionics at Space Rickshaw. So I here at Space Rickshaw, I work on code. I mean, like basically, I write software for satellites. Then any equipment which goes to space. So I take care of this particular piece of technology, and I have experience of, I mean, I have 6 years to 7 years of experience building spacecraft, and I have worked on more than 10 spacecraft, and which obviously which went into space, and they are currently, as we're speaking now, there is one satellite orbiting around the Earth and the other one in the lab waiting for the launch. So yeah, coming to today's session. So today I'll be speaking particularly about a certain topic called ground stations. So everybody speaks about how to build a satellite, how to send a satellite to space, but how do you communicate with the satellite? How do you maintain this communication with the satellite? So how does it align with the theme of our current topic? So basically, a lot of people also think that setting up a ground station for that to a satellite, it's too costly. There's a misconception that the space is expensive. Yes, it is true. Space is expensive, but that is where where we work on, we use something called as commercially off-the-shelf components, called as COTS components, where we use the components which usually, if you think they cannot be used in space, but we make them work in space. We select in a way, and we run it through a rigorous testing and process to make sure that it works in space. So that is what we work here at Space Rickshaw, and then we build satellites for the customers. So yes, so what about the ground stations? So today I'm going to talk about a particular ground station which anybody can set up in their home, schools, or colleges. Like we have helped a lot of remote places and remote areas, and also schools, including government schools, a lot of students, college students, help them to set up the ground station. It would cost no more than 5,000 rupees. If you ask me in dollars, it's less than $100. With less than $100, you can set up your own ground station and receive signals from satellite 24/7. So that is what we'll be talking about today, how the system works, why do we use the system, and what are the components which goes into this, building this system. So this is going to be a primary, kind of a torchbearer session where you can get a lot of information, and you can build these systems on top of it, because within 30 minutes it's a little difficult to explain each and every aspect of this particular topic. But rather, I'll go through briefly into every topic and explain how it goes, I mean how it works. And then that can that I think that should be enough to build ground station at home or school, or anywhere. Okay, let me start my presentation. Just a second. I think I have to rejoin because I have just enabled my presentation option. I'll just rejoin it. Give me a second. Okay, here we go. Now I hope my screen is visible. Is it visible? Are you able to see my screen?
Yes.
Okay. Here we go. Second. All right. So ground station network for CubeSat communication. So a lot of people now they know what is CubeSat and why do most of the universities and other prefer CubeSats. So we are one of the company who has launched most of the CubeSats and satellites. In terms of private space sector, where we have worked on more than 5 satellites. I have previously worked in a company called Space Kits India. I'm currently working at Space Rickshaw, and right now we have renamed our company as Catlex, where we are working on re-entry capsules. So basically, we provide platform for academic research purposes and any technology where they want to send a certain item to space and then test it and then bring it back again. So that is where we work on. We can accommodate the payload into our systems, and we can provide communication, we can provide power, computation, or structure, rigidity, or anything. You name it, we got it. You just have to concentrate building your payload rather than building the entire satellite. So we provide the system, and then yes, so we provide the system, and there is also an option just in case if you want to use certain equipments which is hard to send to space. What you can do is you can select an option and we can bring the payload back to Earth. Like we have a capsule getting ready, so we can put the payload in the capsule, send this to space. This capsule spends a time for almost 2 months in space and then comes back again, and we can give the payload back to you, and then you can analyze with the equipments you have. It's true that we cannot take every equipment in lab and send to space and test it in space, but we can simulate it. We can, give the space environment and bring it back, and you can use your lab equipments to test how the specimen has. Okay, I'll just go ahead. Yeah. Yes, so we need a constant communication with the satellite, because once the satellite is in space, it needs a regular observation, because there is no way we can recover a satellite if it crosses its, there are certain constraints and limits. If it crosses those limits, there's no way we can retrieve the satellite back. Once the satellite is in space, there's no way I can connect my USB cable. There's no way I can change any or not. So why do we need global ground station network? So why do we need it? So the first thing is, if you have a ground station at only a particular location, it's hard to maintain that. It's because the satellite takes a certain time to orbit around the Earth, and it won't come exactly on top of the location in every orbit. So if you're talking about SR0, which we have launched just a couple of months ago, the satellite has got launched, and only once every every day we will be encountering only 4 times over India. So the satellite will be passing over our ground station only 4 times. So yeah. So how do these satellites communicate? So there is something called as frequency. So probably you might have used these radios, right? So every radio, the radio stations have certain frequency, like where you listen audio or advertisements. So it's 98.6 frequency, 98.6 megahertz or 96. Those it ranges somewhere around 80 to 104. So this is the frequency where you'll be listening to music in your car, right? But when it comes to satellites, we have VHF. I mean, not just satellites in general terms. We have VHF, which ranges from 30 megahertz to 300 megahertz. Then UHF, ultra high frequency, 300 megahertz to 3 gigahertz. Then another one is L band, 1 to 2 gigahertz, because this is particularly used by GPS satellite, mobile satellites, military purposes. Basically, this is mostly used by military for the military operations. And then S band, which ranges from 2 to 4 gigahertz. And then C band, 4 to 8. This is where your satellite TV, satellite television would be communicating to the dish antennas. And the next band, this is for deep space communication. And then you got KU band, and then Ka band. So these are for the extreme higher data rates, which you won't be basically seeing in any of the CubeSats because of the size constraint and power constraints. Out of all these frequencies, we are very much keen about these particular 2 frequencies. Okay, so if you look at it, these are all the frequencies available, but I'm just particularly talking about these 2 frequencies. The reason is they are amateur band radio. So the thing is, these 2 particular frequencies from 430 megahertz to 440 megahertz, and then 2.4 gigahertz. Once again, it's 2.4 gigahertz to 2.45 2.4 gigahertz to 2.45 gigahertz. So this particular frequency, this is an amateur radio band, which means you don't need a license to operate. So if you look at it, every satellite needs to get a license. So, and that license can be operated only by the person who owns the license. Let's say I own a license for 470 megahertz. Only I can operate my ground station. Only I can communicate with the satellite, and nobody else can do it. So what can we do? So the answer is amateur radio band. So in this particular radio band, you don't have to get a license, but at the same time, you cannot commercialize the data what you are generating. So what we do is we take this license, we get the approval from IARU. So they give the particular frequency. Okay, you can use this frequency, and they give it to us. And then we start transmitting signals from our satellite in this particular frequency, which can be picked up by anyone. And that is the great part about this. You don't need to have a license in order to pick the radio signals. But let's say if you want to pick signals from our licensed signals, yes, you need a license to operate this ground station. But for the amateur radio band, you don't have to. So for these particular 2 frequencies, you don't have to get any license. Yeah. So yeah. So again, as I just mentioned, that we have to place these ground stations very strategically in order to receive signals from the satellites, right? So I'll give you a small demonstration and how effective it would be placing these ground stations in different parts of location. So I have a map now. How do I even know where do I have to place my, the ground stations? So for that, I have a code here. So first, let me simulate our ground station, which is in India, and I'll show you how. I'll show the problem what we would be facing if we don't have multiple ground station network. We don't have a ground station network. Yeah, so this is the our SR0 satellites orbit. 1 second. Yes. So right now we are looking at satellite, which is passing by. And if you look at the globe, so we have a ground station here. The red dot is a ground station, which is India. Okay. So right now we don't have any communication. We cannot communicate with the satellite. We don't know what is happening with the satellite. Or basically we consider satellite as just a flying brick at this point of time because we don't know what's happening with it. Okay. I'll just fast forward a little bit. So satellite, because of the 30-degree inclination, it takes time. And yeah, now it's just crossing Madagascar. And yes, we are going to approach. I'll show you how this communication establishment would be looking like. So from this point, we'll be able to maintain the green line is a communication. At this point, we can establish communication. So this window won't last more than 5 to 8 minutes. And that too, that depends upon the temperature, that depends upon the clouds condition, and a lot of other factors. At this point, if there are a lot of clouds, you won't even be able to communicate for more than 2 minutes, and that's it. And at this point, yeah, this ground station is out of sight, and we won't be able to communicate with the Earth again until we have the next pass. Probably the next pass would be now again, and that's it. And after this, the orbit would be in a little higher, and now from now on, we won't be able to communicate with it for the next at least 12 hours. And like this, it would be passing just 4 to 5 times per day. So this is the problem we have while maintaining just one ground station when we don't have a network of ground station. Right now, what I'm doing is I have a list of coordinates which we have strategically decided that, okay, this is where we have to place a ground stations. Let me simulate that part. So these are the GPS locations I got. Just give a couple of seconds. Let it load. Yes, here we go. So these are the ground stations. Yes. So these are the ground stations. Oh, come on. Yeah. So if you can see, one thing is, when the satellite is flying over ocean, we won't be able to cover anything because it's a little hard to place ground stations in middle of ocean. But you can see here it's Hawaii. And we have one in US, one west side of US, then east side of US, and another one here. We started getting into Africa now. Sorry, South America. And then the other one. So here you can see there's a difference. Right now, it's the orbit is right above the ocean. But after, okay, I'll just simulate couple of more orbits. Yes. And from here, you can see, I'll bring it back here. Yeah. Yeah. So we started communicating with this ground station immediately with this one. So there will be a blackout for 5 to 6 minutes. And then we got here and then here. Just a second. So in Europe, we have a lot of ground stations. So as you can see here, there is a constant communication. But from this point, it's almost a 45 minutes journey. We have communication here and then here. Immediately we'll switch to here, here, and then here. Other one. As you can see, we have a constant communication and there is a very little delay. I mean, when there is a little downtime, which is fine, fine because we have to sleep for some time. Yeah, we can consider that as downtime. And then, yes, so these are the places where it is possible to establish ground station. And yes, there are ground stations here and we are able to maintain that constant communication with the system. So yeah, let's go back to our presentation now. So how do we build this system? Like, okay, I have multiple ground stations. How can I coordinate with these ground stations and get the constant data? And how can I maintain this constant communication so it does not affect my operations? Or let's say if I get a signal and if it is being captured by multiple ground stations, how do I differentiate that this is the same signal? I cannot run these ground stations independently. There should be a system which has to coordinate all these ground stations together and control them together. So that is the architecture which we're going to discuss now. Okay. So I'll just go a little bit further. Yes. So this is a basic ground station setup. Okay. Where you need to have an antenna. Okay. And then LNA, which is a low noise amplifier. Then a radio to modulate and do all the basic stuff which is needed. And the microcontroller to convert the data. And then a Wi-Fi modem to either put it. This is optional. You can have it. If it is there, that's much better, because if there's a Wi-Fi modem, you can relay it to any any of your nodes or any your server or anything like that. So yes, we need to have a server. From Wi-Fi modem, we send the data to a server. Whatever data we have received from the antenna, which has been processed by our radio, will be sent to a server. So how do we send this data? There should be so they usually, if you are into software engineering, you might be familiar with REST APIs, where we use APIs, REST protocol APIs, where we do GET protocol, POST protocol. So that doesn't work here because we need to have a constant communication, and we would be using a protocol called MQTT. So this is widely used in IoT. So we use this particular protocol to establish communication between our ground node. We call this as node. So from the ground node to a server, we maintain this one, and then we store all this data into a database. So this is our entire server architecture. This is our node architecture. So now how do we scale this up? It's simple because we can just replicate this part, okay, this particular system, and then scale it up. So we can have multiple of these nodes, and then that will be, every node will be connected to a server, and the data will be transferred via this protocol called MQTT. So let's say we have a customer and who wants this data. So they don't need to maintain the ground station. They don't need to get an antenna, maintain, service their routers or antennas or anything. It's simple. They just have to, maintain communication with the server, and they would be getting data whenever they need. This can be REST APIs because it's just on demand. But here the data will be received at a random interval, and then that data will be relayed. So we use MQTT. But when it comes to delivering data to the customer, it would be REST APIs. So now, how do you build this entire part? So I'm just talking that, okay, we need an antenna, LNA, and then radio, Wi-Fi modem, and it's a, you have to build it, right? There should be a process, and there should be a system, and it would cost a lot of money, right? The answer is no. You can just simply get this module called Heltec LoRa V2. This is the board which you can get it directly from Amazon. It's available everywhere. So what you can do is you can buy this particular chip, which has inbuilt LoRa chip. It has inbuilt Wi-Fi modem. It has a microcontroller. It can do everything. So there is, okay, I'll come to the topic. Yeah. So this server. So what about the server and the database? How do you so where do you connect to this? Do you connect to our servers, or where do you connect it? So the thing is, there is an open source community called TinyGS. So what you can do is you can buy this board, and then you can install the software what TinyGS is giving you, and automatically it gets connected to the TinyGS network. You don't have to write any code. You don't have to maintain. You don't have to talk with the satellite operators or anything, because TinyGS maintains that communication with the satellite operators, telling that, okay, when the satellite is going to be at this location. You just have to feed your longitude and latitude into the board, so it knows when and where the satellite is going to be, and what satellite is going to be above your head at a given point of time. So TinyGS would send that, okay, there's a satellite passing by. You collect this data at this frequency and give it to me. That's it. So it just does everything automatically. Okay, so this is the chip which I was talking about. This chip cost you somewhere around $40, and that is enough to receive signals from satellites. So at this point of time, I want to give you certain examples. One. So you might be thinking building an antenna is tough, right? So it's very difficult to build an antenna because receiving signals from satellite is no joke. But I'll show you how we build antennas and how people have received. So you won't believe, this is the antenna which one of my friend built, and it was able to receive signals from our satellite. That's all. You can, if I zoom it in, it's just two, just two wires at a perfectly cut length, with I don't know what exactly call this. Maybe I can call it a screw terminal, and then just a SMA cable going into the TinyGS board, into the Heltec board which I just displayed. That's all. This is the antenna setup. So this is one, and then the other one is this one. So if you look at this is not even he did not even strip the wire. It's just the TV dish antenna. You have these TV dishes, right, for receiving DTH antennas. So the wire SMA cable from that, he just picked it up and then got it cut, and then just sticked it on top of a ruler, and then he was able to receive signals from our satellite. And not just that, you can build complex antennas. So if you look at it, this is me sitting here. So yes, this is our office. This is a cardboard plate on which it's basically we need a metal object to reflect something. So what we did is we took a cardboard piece and wrapped an aluminum foil on top of it. This is just an PVC pipe laying around, and this is just an copper wire at a certain thickness and a certain gauge. I can you can find these calculations very easily online. So just winded it around, and this is the dustbin, not even some sort of special equipment, just a dustbin. On top of it, we were placing it, and we were able to receive signals from Chinese International Space Station, Chinese Space Station. Then a lot of like more than 20-30 satellites. We just left it around, and we were able to receive with this just an antenna built from junk. So it's not costly, or it's not impossible to build something like this. It's very easy. School students or college students or anybody at home who's enthusiastic to build something like this, it's possible. Okay. Yes. And yeah, going ahead. So how do you know the satellite is coming over your head? So that is something we use. We use something called as TLEs. I won't go much deeper into it because I think we are running out of time. I'll go a little faster. So we use something called as TLEs. It's called as two-line elements. So we use this formula. It's basically, you can consider it as a magic box where you give time, it gives you where the satellite going to be. So it's as simple as that. So there's no electronics involved. It's just physics, a pure physics mathematical model. You just give the time, it gives you where the satellite is going to be. Yeah. So what we usually do is, in order to increase the accuracy to the existing architecture, what I do is we add azimuth and elevation motors. Basically, instead of just leaving the antenna out like that, we prefer the antenna to be connected on a motorized platform where we can move the antenna and point it exactly where the satellite is. So using the TLE, we can calculate where the satellite is, and then we can find the X and Y axis according to our position. So we call this movement as elevation and this movement as azimuth. So we use two stepper motors. Okay, so elevation motor and stepper motor. We drive through motor drivers, stepper motor drivers, and these will be connected to the same microcontroller, which is receiving data from our antennas. Okay. So yeah, our communication systems, there is something called as full duplex and half duplex systems. So a full duplex system is when you can communicate and like you can send signal and receive signal at the same time, as we call as full duplex system. So the SR0 or most of the amateur band radios, they use half duplex system, which is only one way. It can be either, you can either send or receive. You cannot do both at the same time. So this is the system we usually opt with, because we don't like to buy an additional frequency for transmitting and receiving at the same time. And also, it's not, right now we don't have to do it, because our payloads, whatever we have launched till now, they did not have this requirement that they want this uplink and downlink at the same time. Yes. So in that case, if you want to switch between same frequency, so what you can do is you can have an power amplifier, which when you want to transmit something to the satellite, you can add in power amplifier, which amplifies the signal which is being transmitted from your ground station to the satellite, and that can be connected to the antenna. Yes. So I think, yeah, I think we are running out of time. Maybe I'll just now skip this part and go to a Q&A session. I can answer questions if you have any, and then we can go ahead. Yes, if anybody has any doubts, yeah, I'm ready to take it.
Thank you, Katan. Really appreciate your section. Thank you. Please, if you have any question, can you drop it in the chat section? So before anybody drop a question, I have a question for you.
Yes.
So
yes, please.
Please, which software do you use for your coding? For coding the satellite? Yes. Which software do you use?
Got it. Okay, there is no specific one software we use for satellites. It depends upon what you're building, because satellite, there are multiple components inside. We have, let's say, if you're writing the software for the main onboard computer, the the computer which operates everything, the brain of the satellite, we basically use C language, C, C++, and sometimes we go with assembly, but mostly it's C, C++. And then let's say if you're going with any high processing or any image processing systems, there we use Python. We basically don't prefer using Python in the main flight software because Python is one of the most slowest language, and C is the I could call it as one of the fastest language and less bulkhead, because the resource we have here, the RAM would be in KBs. It's not something we get it on, not even phones. To be frank, our phones are 1 million times powerful than the computers we use in satellites, because we don't need them, because we don't need UI, we don't need high computation. Satellites are simple, computation. So what we do is we use very stringent RAM, stringent computation resource, and then use C language so we can have a good control on top of it. Then as I just mentioned, anywhere there is imaging or any processes needed, there we go with Python. And also like for the ground stations and other systems, we go with JavaScript, Node, Go language. So yes, the answer is a lot of languages, depends on what we are building.
Oh, all right. I think someone also dropped a question in the chat section.
Yeah, thank you. Thank you, Kirtan, Space Rickshaw. Very nice to hear from you. I'm fascinated. I'm an industrial engineer. So anything to do with electrical and satellites kind of has me, oh, this is not as challenging as I thought it would be. But you've made it very simple. You said, I want to go back to your start about needing to have communication with a satellite. Is it that your particular satellite, the one that you are speaking with, you want to, what are you actually trying to capture with that satellite?
Actually, I did not get your question. You mean
so
system
you
what you're
have,
building specifically for our
so you
satellite?
have, you were saying that you have a satellite and you want it to be in constant communication, right? I was wondering if this was your particular one that you had already done, or is it just a hypothetical satellite that you were talking about? Because then how would we, if we wanted to do something across Africa, for example, right, a constellation, and we wanted to map rainfall or water, how would we then use a network of schools, for example, to do ground stations in every country to actually do something like this in reality?
All right. So the problem which I just mentioned, it's not just for our satellite, it's for any satellite which is getting launched. So yeah, that's a common problem. And the solution, what I just proposed, is not satellite which is going to space, but not the satellites which are licensed satellites. I'm just talking about the amateur satellites. So if you ask me how many of these satellites are in space right now, there are more than 40 to 50 of these satellites currently orbiting. Basically, you can expect one satellite once every 20 to 30 minutes over your ground station if you're setting it up.
Okay, so you said that we could buy this right online and do it easily.
Yes.
Do you have like a module available if somebody wants it? I would love to test it, for example. Do we have a module available that I could say, give it to some of my students and have them do it? How would we just get a sense, and can we then look at your training, do it ourselves, and then come back and say to you, hey, we've tested this, then what? How can we build on this? Because I'd like to have it not just be an academic conversation. I'd like it to be that something we actually try and do what you're saying. How might we go forward?
Maybe I can share the resource which is needed for this. I don't know whether there is a module or something which is available, which actually we did not make it at Space Rickshaw. But I think I'll look at any a building guide or anything which is available, which is easier to set up and then do it, because it is a very simple process. It would take no more than 1 day to build it. I mean, if you have all the components with us. So maybe I'll just have a look at any video or anything which is available, which can be shared with everyone, and that can be used to build this system. But the TinyGS, you can just search it. It's all over the place. A lot of videos and a lot of people have built it. So yes, it's available. But maybe I'll find a good one and I can share it.
I'd appreciate that. And then we'll be back in touch with you.
Sure.
Thank you.
Thank you.
Yeah, we'll appreciate all of us, I think. Thank you.
Thank you so much. Yeah. Any other questions?
Thank you, Katan. We really appreciate your time. I think someone also dropped a question. The person asked that how do you think I can start learning programming for satellites? Which language is the best?
Just a second. So there's a question in the chat box.
Yes.
1 second. Let me. See. So yeah, how do you? Okay. Please can I have chat with you? Also, I need recording. How do you think I can start learning programming for a satellite, and which language is best? How do we can? Okay. So yeah, programming a satellite is no different from, you're programming electronics. So it's simple. Like you just have to be very good with your fundamentals. You have to just follow certain steps when you're programming a satellite. If you're good with programming your embedded systems and building, time critical, time constrained projects such as drones, and then some sort of vehicles where, especially drones is a really good place to start. Not something you just assemble everything and then fly it. I mean, programming the drone from scratch. If you can do it, you can, start building the satellite itself, because a lot of things would be, covered with in that topic. So you have to be really good embedded systems, electronics, then and also computer science, and also architecture and all these things. Once you're good with these, you just have to make sure that radiation is one of the most critical problem in space. You have to know how to tackle this. So you can software wise, you can enable certain things. Hardware wise, you can tackle radiation that you have to look at. And apart from this, there is one big problem, which is, once you program satellite, once the satellite is out of your hand, there is no way you can get it back. So once you program, you have to plan every problem. You have to plan everything which is going to happen in the coming next 2 years for the satellite. There is a chance that sensor might fail. How your satellite is going to handle if you can't provide a software update? So everything has to be planned. Every failure condition has to be addressed and pre-programmed. So your satellite should be able to diagnose itself and recover itself. This is very, very, very important. So more than building a satellite, we take time testing the satellite and analyzing the performance of the satellite. Because if something goes wrong, that's all. Your satellite is dead. It's just a flying brick in space. So yes, you have to be really good. You have to, it's all about patience, and then thinking ahead of what might happen with the system. And that you will get when you're really good with the systems. I mean, in terms of electronics and programming. So yeah, long story short, there is no particular course or any fixed path to get into satellite programming or satellite building. You just have to be good with your electronics, and you should be able to apply this topic, I mean, this your knowledge into this domain. Also, can I get your contact? Contact of the speaker that's currently. Yeah. Yeah, I can give my contact. Maybe I can drop my email. Kirtan at. Yes, I'm just dropping my mail in the chat box. And also I'll share my LinkedIn profile. Yes, there's my LinkedIn profile and my email.
All right, thank you, Mr. Cotton. I really appreciate your time. It's such a wonderful presentation. We all learned a lot from you today. So thank you. Really appreciate your time. Yeah, thank you.
Thank you for inviting. Yes, thank you so much.
So we hope to see you again tomorrow for a panel discussion.
Sure, I'll be there.
All right. Okay, as regarding all the asked questions, as regarding the audio recording for the whole convention, everything will be available after the convention, and that's tomorrow. So to get to for you to know when it's it drop on our pages, I would like to follow us on LinkedIn. Search for MARVECX on LinkedIn, so you can follow us. And as regarding the contact of all our participants, You can also check our LinkedIn page. You're able to get their direct link to their profile page on LinkedIn. So through that, you can send the connection request to them and ask whatever question you want to ask them. And through that, you can also gain your connection and relationship with them for some other things. So thank you all for joining us today. Thank you, Dr. Claire Nensing. Thank you, Mr. Katzin. Sorry, I hope I correct. Please, can you pronounce your name again? I don't want
That's okay. It's Kirtan, but no problem. I understand. That's no problem.
Okay.
Got used to it. Yes.
So thank you all for joining us today. So tomorrow again we meet. Today we are able to we have 5 guest speakers in live of Dr. Nessing, Mr. Katin, Dr. Mr. Juice, and Dr. I can't remember the name again. Really? So we shall thank we are able to learn from 5 different guest speakers today. Yesterday, 4 guest speakers spoke with us yesterday. So we make it net total guest speakers. For tomorrow will be panel discussion, whereby all the invited guest speakers, those who are opportune that will join us tomorrow, we're able to share more light on the theme of the convention. And also, if you have any question, during the press of the if you have any question during the press of the panel discussion, you can also drop it. So we'd like you to follow us on our LinkedIn page, MARVECX, which I will later drop. I would like you to give me like 3 minutes before you leave this convention today, so that you're able to follow us on LinkedIn. So that I will send the link on LinkedIn later in the day, whereby you can drop your question that you want to ask the invited guest speakers, or there's something that is kind of bothering you as regarding how we can promote the sustainable development goals in space exploration, in technology, in engineering, in sciences at all, or not even sciences. There are some areas that we can also implement and sustainable development goals into. So in such a way that you can drop your question there, and tomorrow we'll be able to address all during the course of the convention. Thank you all for joining us. Thank you for joining us. Thank you. Okay, and I've already dropped the LinkedIn page where you can follow us. All the recording and video for the convention will be dropped later after the convention. So don't worry, we recorded, everything is recorded. Don't worry, you get all the recording. So see you tomorrow. Thank you all for joining us today. See you tomorrow. Thank you. Bye. Okay, bye for now.